All right, welcome everyone to our first ever time doing a panel at BayLearn. This panel is focused on AI safety and alignment. We are very excited for this opportunity to have three amazing researchers and practitioners in this field here with us today. I personally think that this is a really important topic, and I'm really glad and excited that we are paying a lot of attention to it and spending some time today talking through it. So the way we're going to work through this panel is I'm going to introduce our panelists, then we have a few questions that we're going to talk through on AI safety and alignment, and then we'd really love for y'all to participate. So there's a link over here and a QR code that you can use your phones. Please add questions to Slido. You can submit your questions, and then you can see other people's questions. You can vote on them. Towards the end of the panel, I'll start picking from those questions. So you can start putting in questions right now and vote on other people's questions, and then we'll pick from them to ask. So I'll get started by introducing our amazing panelists. First from left is Joaquin Quinero Candela, who is the head of preparedness at OpenAI. He's done a lot of amazing work on human-AI interaction, focused a lot on building safe AI systems at OpenAI, focusing on safety, policy, culture, social topics as well. He works with a team and supports a team at OpenAI called AI Safety Team, and they look for a range of things around preparedness for frontier capabilities that are emerging, and the risks of building model policies, and looking into ways of building these model policies and structures that align with human laws and values. All of our panelists are amazing in the sense that they do multiple different things at the same time. So they're very technical, but Joaquin is also on the Spanish government's advisory board on AI and has been on the board of directors at the Partnership on AI, which is an organization that is focused on the societal consequences of AI and looking into them. Our second panelist, Stuart Russell, is a professor in EECS at Berkeley. He's also the director of the Center for Human Compatible AI, as well as the director of the Kavli Center at Berkeley for Ethics, Science, and the Public. He's done a lot of amazing research ranging from ML, probabilistic reasoning, knowledge representation, real-time decision-making, as well as really looking into the philosophical foundations of these things. He's also done a lot of work in policy around the ethics of these tools. He was one of the people who developed the Global Nuclear Explosion Monitoring System for the United Nations, has done a lot of work on these sorts of global policy issues, as well as the long-term future of AI and its relation to humanity. He's the author of the book Human Compatible AI and the Problem of Control, which I highly recommend. And finally, Joshua Stoll-Dickstein is, he says, infamous for inventing diffusion models. He's done a lot of work focused on the theory of over-parameterized neural networks, meta-training for learned optimizers, and really understanding the capabilities of large language models, which I think is really important. He recently joined Anthropic as a member of their technical staff. Previously, he was at Google Brain, Google DeepMind, as well as Khan Academy, which is an educational nonprofit, which I'm sure you know about. One thing that I didn't know about him, which I recently learned, is that before he got his PhD, he worked on sending rovers to Mars, which is very impressive. And one of the things that I really like about what you've been doing is really looking into how are these models working, and how do we really measure how they're working? How do we quantify and extrapolate the capabilities of language models, which I think is really important in this conversation. So I'd like to thank you all for joining us today. I'm sure this is going to be a really interesting conversation and really engaging. And I'd like to start with a little bit of an icebreaker and to get to know you all better. So I'm going to ask this question of all the panelists, which is, what brought you to this? There must have been a backstory of how you got interested in learning and doing research on safety, alignment, and these issues. And I'm going to add a second sub-question to that, which is, what keeps you up at night? And so I'd like to ask each of our panelists, starting with Joaquin, to answer that question.
Yeah, hi everyone. Thank you for having me. I don't really know what brought me here. I think people are good at explaining their deliberate paths in their careers, but I think in practice, I think things sort of happen in a way. I remember when I was in high school, finishing high school, I had a pretty terrible dilemma. I absolutely loved math and I loved physics, but I also really loved philosophy, and I went to a French school in Morocco. That's a longer story. And I really absolutely also love the humanities. And I was at that crossroads, and I decided to do engineering because I thought if I don't do that now, I may never do it. And I naively assumed that then I could catch up on the humanities later, which has proven to be a lot harder than I thought it would. And then fast forward many, many years, I went from academia to industry. I remember working at Microsoft Research and working on click prediction on ads to increase the relevance of ads. And I remember the question, and this is many, many years ago, of like, oh, should we be using gender as an input into these algorithms? And no one had an answer. Like we're talking 2008 or something like that, right? This was before the FACT community and many other communities. And those questions sort of stayed in the back of my mind for a while. Then I went to Facebook, and at Facebook, one of the things I did is I built the Applied ML team that sort of supercharged the use of ML across the entire company. It was amazing. It was extremely stressful as well. And I remember almost burning out, or maybe I did burn out as a result, and sort of resetting a little bit. And I remember my boss, our CTO back then, saying, well, what would you do if you could do anything? And then all of these latent concerns came back to me. I think things sort of go with you, through life. And I remember saying, well, and this is like 2007, this is like 2017. I'm like, I think we're like way underinvested in understanding the ethical concerns of the success that we're having in supercharging the company with ML. So I'd like to work on that. And I had no idea where to start. And then I was talking to people, and then someone pointed to the ProPublica study of bias in risk prediction for recidivism in the criminal justice system, right? So I read that paper. I read then John Kleinberg and team's work on explaining that fairness, AI fairness, is extremely complicated because both math and philosophy disagree on what is fair. And all of a sudden, maybe all of these latent passions, like me having been at that crossroads between the humanities and technology kind of like just reignited violently. And I spent a couple of years doing that at Facebook. I built a responsible AI team there. Then I went to LinkedIn. LinkedIn was an amazing place to work on AI fairness because it's existential to LinkedIn to make sure that the algorithms used at LinkedIn are as unbiased as possible. We wrote an interesting paper that has the word disentangling in the title that I think is interesting because we managed to operationalize how to address fairness, which is a very politically charged topic. Now I'm at OpenAI, where I focus on preparedness, among other things, and I want to make sure that my other panelists here also get to say something. So I'm gonna shut up for now, and then I'm sure we'll talk more in the questions. I forgot to say what keeps me up at night.
Yes,
we'll get,
no, please, we have a few minutes.
I don't.
You can't get out of that question.
I was trying to dodge it. Honestly, it's maybe like the unknown unknowns, I think, and also the fact that I think we're only starting to understand even how to reason about risks. One of the things that I'm obsessed with is trying to have calibrated discussions about risk, and I mean calibrated in the broadest possible sense, right? Because it's very difficult to be. How do you agree on severity, right? Like reasonable people will disagree on with all likelihoods being equal of risks, right? Some people are going to care, given their values or political views, are going to care about some risks versus others, right? Like some people have deep beliefs about different models of society, and there's no right or wrong. And so these discussions get extremely messy because you end up mixing politics and values with science. So again, I'm where I belong apparently. But I think whenever I see discussions that seem to get stuck, where I feel like we're not making progress, I think that's one of the things that keeps me up at night.
Thank you. Stuart?
Okay, so how did I get here? I didn't like rugby very much in high school. And there was a local technical college that started up a computing science A-level. And they asked if people from my school would like to join, and it was the same time as the compulsory rugby. So I definitely decided to join the computing program. And as soon as I got my hands on a computer, I just wanted to make it intelligent. So I guess I wrote my first AI program 48 years ago. I didn't know it then, but it was a reinforcement learning program that learned to play tic-tac-toe. You might say, well, tic-tac-toe is a bit small, isn't it? But the computer I was running on had a 6 microsecond cycle time and 8,000 words of memory altogether. So you couldn't do very much. And I guess the question of what if we succeed has been on my mind for a long time. I mean, as a kid, I read science fiction, and there were dystopian outcomes from superintelligent AI, and there were others. So Heinlein, for example, has superintelligent AI systems that are very helpful to people. And so this question, the first edition of my textbook in '94, has a section on what if we succeed. And it talks about I.J. Good's description of the intelligence explosion from 1965, and various other concerns. I think Marvin Minsky expressed concerns like, what if you just ask it to compute the digits of pi? If it's sufficiently intelligent, it'll take over the entire Earth and turn it into a supercomputer to compute more digits, and so on. But if you read that section from '94, it's sort of cautiously optimistic. It says, yeah, it's a long way off, and we'll maybe figure it out as we go along. And then I took a 2-year sabbatical in Paris in 2012, highly recommended. And, and at that time, I think several AI researchers were beginning to see that there might, in the dim distance through the fog, we could start to see a roadmap that might lead to AGI, right? I mean, AGI had been the goal of AI since the beginning. I mean, it's very, very clear that that's what we've been trying to do. Now, the roadmap that I think we glimpsed through the fog does not resemble what actually happened at all. So, language models were not relevant, really, except for a bit of speech recognition back in 2012. But as I thought about it, it just became clear that we did not have an answer to the following question. How do we retain power forever over entities more powerful than ourselves? And one of the things I did not know at the time was that Alan Turing had given a lecture in 1951, and I think he had that question in the back of his mind, and he said, what if we succeed? Well, we should have to expect the machines to take control. So since then, since about 2013, I've been trying to figure out, is there an answer to that question? And I think there may be, and it involves reconceptualizing what it is we're trying to do when we build AI systems. The traditional way of building AI systems until recently was we specify an objective, whether it's a goal for a problem-solving system or a planning system or a reward function for a MDP solver or a reinforcement learning system, and so on. We have seen, as we try to transition systems into the real world, that that approach fails. We call this the King Midas problem, where you misspecify your objective and then you're screwed. What we're doing now with large language models is actually imitation learning, where we don't even have an objective. They probably, as a result of learning to imitate humans, they're probably acquiring objectives from the humans who are generating all of that text or video or whatever it is. They generated that text for a purpose. And so, in the limit, you start to resemble the data generating mechanism. And if that mechanism is humans, you're going to start to resemble goal-seeking humans. But then you've got AI systems that are pursuing unknown objectives on their own account, which is probably wrong. Well, it's not probably, it's definitely wrong. So there may be a way to avoid those failure modes where we build AI systems that pursue human interests on behalf of humans, right? Their only goal is to further our interests, but they're explicitly uncertain about what those interests are. So that can be formulated mathematically as an assistance game, and then we can show that assistance game solvers have desirable properties. We necessarily benefit from their existence. We can always turn them off and stuff like that. So right now, we're in the middle of, well, I would say at the beginning of a massive regulatory fight. And it's somewhat analogous to the fight that happened between the human race and the fossil fuel industry starting in the 1950s, which the human race lost. Mm-hmm. Now we're having another fight between the human race and those who are developing AGI without any means of preventing the carbon dioxide stuff from happening, or the equivalent of carbon dioxide stuff. So, so that keeps me awake. Another thing that keeps me awake are lethal autonomous weapons. So for those of you who haven't been following that discussion, they already exist, they are already being used. They are starting to resemble the weapons that we illustrated in the Slaughterbots video that I made in 2017. Because they're autonomous, you can launch as many as you want. So by pressing a button, you can kill 10 million people. And therefore, that, in my view, constitutes a weapon of mass destruction that we are about to start selling in the Walmarts of the arms world. What could possibly go wrong with that? I guess the other thing that's keeping me awake at night right now is trying to run a faculty search at Berkeley, hiring 5 faculty on the topic of AI inequality in society between computer science, statistics, the information school, sociology, and the law school. So trying to get all those 5 departments to cooperate on one faculty search in this area. But it's super fun. Thanks.
Thank you for that. Joshua?
Cool. I'll try to be brief. Maybe one comment. Stuart mentioned that like autonomous weapons keep him up at night, and this keeps me up at night also. But maybe the specific fear I have about them is not the ease with which you can kill, but the fact that they're almost like unattributable. In that if you there's a lot of systems in place that prevent us using like violence for political ends between nations, and a lot of those like systems depend on the fact that when it happens, you know who did it. And I think it's very, very hard to understand who sent like an autonomous drone to like assassinate someone. But I should zoom out of my own career. I think I got here by a random walk. I think the generous interpretation is when there was something that I thought was important or exciting, I was willing to take it. But I did physics in undergrad. I never attended class at all. I like somehow got a job at JPL working to send onto Mars rovers. Afterwards, it was like pretty exciting, but I kind of wanted to do my own research. So I applied to grad school. I applied in like a whole bunch of different departments. I ended up getting into a biophysics program at Berkeley, but then I joined a neuroscience lab. But then over the course of my PhD, I kind of stopped doing neuroscience and started doing machine learning. And then I left, and for 2 body problem reasons, I did something like a postdoc at Khan Academy, like kind of building probabilistic models of like students learning, like human students like learning human concepts. And then I went to Google and did like straight up ML, and I guess here I still am. When I was a kid, I read nothing but I read like every science fiction book in existence. I am like we are living the dream in that we are building intelligence. We are doing the things that seemed like fantasy when I was a child, and this is like amazing and incredibly exciting. The flip side is I think it is going to be an incredibly disruptive new technology. I think, and maybe we can get into this later in the questions, but I think that there's not just one risk or one possible benefit. There is like a wide diversity of ways in which things can go horribly wrong or wonderfully right. And it's all gonna happen very, very fast. And I also have 2 kids who are like, you know, in first grade and preschool. And I think I worry about how the future is going to unfold. I'm like excited about it, but also I'm quite worried about it. Yeah.
Thank you. A lot to think about there. And thank you all for adding your questions. I've been monitoring them, and we'll start asking from that list in a little bit. I think one of the things that came out of all of your answers were these sort of, and sometimes this causes some arguments in the AI community around these near-term risks and the long-term risks that are coming. I wanted to hear how you think about sort of the risks that are here right now, or the harms that are happening right now, and what you think are the most pressing ones, and what are some approaches that may work. And any of you who wants to can respond.
I guess I'll start by talking about disinformation as one of the risks. And you know, a lot of people at the beginning of this year said, "Oh my God, we got all these elections coming, and there's a huge risk of these elections being disrupted or distorted by disinformation." And I would say the reality has been a little bit less than people expected, but still significant. And there have been several elections this year that have been distorted or disrupted. And the volume of disinformation is now pretty massive. Some of it human produced, but a lot of it aided by machine tools. And everyone has perfectly good ideas about what to do. So image generators should, you know, invisibly label their and indelibly label their outputs. That real image generators, so cameras and video systems and so on, should also label their outputs with provenance. So you've got all the real stuff is labeled, most of the fake stuff is labeled, right? The legitimate fake stuff. And then you've got the unlabeled, illegitimate fake stuff. But the more you can squeeze that from both ends and provide tools. So expecting a user, they get something in their feed and then somehow they go to like drag it to some app and say, you know, check this and tell me if it's real. I mean, come on. That is so unrealistic and pathetic, right? The only way this is going to work is if the platform gives you an opt-in feature where you say, I do not want to see fake video, right? Or if I see fake video, it's labeled with, you know, it has a big magenta, semi-transparent rectangle over it. So I learn, and that has to be standardized in the same way that red, yellow, and green traffic lights are standard all over the world, right? And we don't even think, okay, red, let me look at my book and see what red means, right? Yeah. It's just instantaneous and accessible. So this means that, and there are, there's dozens of standards for watermarking, there's dozens of standards of provenance, meaning that there are no standards for any of this. So I think governments have to knock people's heads together and say, agree on something, that's technically solid, and then we can improve it, but get something in place.
Yeah. Let's go, Joaquin.
Yeah, I'll add a couple of thoughts. We've been testing the ability of our latest models for persuasion, for argumentative reasoning, and we published a system card for O1 previews. If you just Google O1 system card, you'll find it. And one experiment we did, which is really interesting, is there's a subreddit called Change My View. Does anyone know Change My View subreddit? Some people do. Okay. And the way it works is like, people state a strong opinion about immigration, about abortion, about minimum wage, about some topic that generates passions, and then other humans try to post arguments to convince them otherwise. And it's a really interesting community because people will admit if their opinion was changed by the arguments of some other humans, they'll say it, right? And so, but that gives like a pretty amazing data set to start from, because then what you can do is you can use an LLM to try and do the same, right? And then you can build rubrics and evaluations to see whether the AI does better than the best humans in that subreddit. And we're getting to the point where I think what we publish is like, the AI does better than about like the 80th percentile of humans there, right? And this is going to keep improving, right? So I think to Stuart's point, it's not only about aiding humans to generate manipulated media. It's actually, you can actually have an agent engage in a conversation with someone and try to persuade them. And of course, there's been articles published about positive uses of this, for example, to debunk conspiracy theories and things like that, right? And another point that I wanted to make is, I think we're not there yet. I mean, we talked about autonomous lethal weapons. One of the things that we think a lot about is threat models, right? We think about, okay, can these models be used by someone who wants to create a chemical, biological, radiological, or nuclear threat? Can these models assist them? And you have to, in your threat model, you have to say, well, can they help experts create novel threats, which is a problem, right? Because we tend to be prepared for threats we know. Or even worse, actually, can they help non-experts create, massive scale harm? And, if you can use a model to create a new virological or biological threat, like synthesize a new type of bacteria or virus, that is very highly transmissible, you can potentially create a pandemic for which we're not prepared. And I think you mentioned tens of millions of people. This could go far beyond that as well, right? So these are like things that are a little bit on my mind in terms of short-term threats. And then maybe for later, I'll just put that, but I won't discuss it, is I think many of us are working on agentic systems that can use tools. I think the capabilities we're seeing there, especially now in the age of reasoning, we see also like a pretty significant jump in capabilities. So I think I don't have concerns like yet, but they're coming.
Mm-hmm. Thank you, Joshua.
Cool. So I think those are great present day negative potential externalities. I actually am going to do one that's a little bit more abstract, but is maybe nice in that I think there are like some research problems that are a little bit ML theory, a little bit ML practice that are in this space. So maybe it's like actually actionable by the audience instead of by some distant policymaker, which is there are many systems in our world that rely on the fact that we optimize things inefficiently. So for instance, we elect the president. Our goal is like to get a president in the US that like will act in the like best interest of the populace. And our like objective we use is like maximize the number of electoral votes you get. And if you do like a kind of crappy job of maximizing the objective, then you do like a kind of crappy all right job of finding someone that will fill the role. If you like over-optimize the objective, if you're like incredibly efficient at optimizing for this misaligned objective, then you end up with like failures where the person in power is like narrowly optimizing like for electoral votes at the active expense of potential like political or real world outcomes. And this is like exactly overfitting in machine learning. When we like have a train set that's different from our test set, then at some point your train set keeps on getting better and your test set does this. If there's one thing that ML systems are going to do, it's that they're going to make many things throughout society much more efficient. like there's lots of laws and design choices and social norms which are slightly different than the thing that we actually care about. And as we optimize against the explicit objective harder, as we have systems that enable us to optimize against these explicit objective harder, we're going to find that a lot of really unexpected parts of our society start breaking. So why is this a research problem? This is a research problem because we can export perhaps some of the techniques we have to avoid exactly this problem in machine learning into broader fields. Can you find ways to like regularize essentially can you find ways to regularize situations where you might overfit in broader society?
Mm-hmm. Thank you. This was
which, by the way, if I can jump and disrupt a little bit.
Yeah.
I think institutions like how government works in the U.S. luckily has a lot of hurdles and regularization, so that it's difficult for any individual to rapidly cause havoc.
Yeah, friction is like good, right? Yeah. In some sense.
Yeah. I'm really glad that we're touching on all these various intervention modes, right? You've got policy, you've got social norms, you've got technical interventions. I think everyone agrees that a combination of all of these things is going to be needed as we go through this massive technological shift, and it's going to take a lot of work. Most of the audience are technical researchers, so I wanted to ask the question, what do you think are the most pressing technical research questions right now? What are the things that if we technically knew how to do, then that would, move us much better into the future and more prepared into the future?
So there are some obvious. So interpretability maybe is like the lowest hanging obvious one. These models are currently black boxes, and if we want to both understand and predict and control their behavior, then we need to understand how the pieces inside that black box work. So there's like interpretability, alignment, maybe not, depending on what future we're actually moving into. There's I think probably the most work, though, is needed at the interface of the technical and the social and the political. So I think there are really, really interesting pure theory or pure empirics questions you can ask, but I think where you could probably really have the most leverage is if you take your technical expertise and apply it to how these things are actually going to interact with the world at large.
Mm-hmm. Yes.
So I guess maybe the flip side of interpretability, there are technological approaches to building AI systems where interpretability comes for free, right? Mm-hmm. And so we could think about a development path where we build on those technologies. For example, probabilistic programming is one case.
Does that give you interpretability for free?
Yep, because you can read. Each piece of the probabilistic program is, at least in a declarative probabilistic programming language, each piece has declarative semantics. It's a statement about the world.
So this is like probabilistic programming with no learned latent variables, just like a...
No, you can include learned latent variables. It helps to scaffold the new ones on top of stuff you understand. And I've tried this where it does learn new predicates and so on, and you can usually understand what they mean. Another direction is what we call a formal oracle, where you can have an arbitrary AI system, but the only thing it's allowed to do is decide on the computational steps taken by a mathematically sound reasoning engine. So the simplest one would be a logical theorem prover, but could also be a probabilistic reasoning engine. And there, I think it's reasonably easy to prove that that system taken as a whole is safe, regardless of what the controlling AI system wants or is trying to do.
Because it can't do anything else.
They can't do anything other than
Yeah.
choose reasoning steps.
Yeah.
And the whole thing is an oracle in the sense that you can literally restrict it to answer yes or no when you put in a mathematically defined question. And this is still an incredibly useful technology. So you can use it to synthesize guaranteed safe software. You can design skyscrapers. You can do all kinds of things, and the output is just an answer to a logically defined question based on some knowledge base. And 10 years ago, we ran one of the first meetings of our what became the Center for Human Compatible AI. We asked, what would happen if in 10 years' time AGI emerges, right? If you knew that was going to happen, what would you work on in the intervening period? And that was the answer we came up with, because there it's reasonably easy to prove that it's safe, but it's still enormously valuable economically.
Yep.
So that's one possible idea we could pursue.
Thank you.
I would only add very quickly, maybe this is a shorter term research objective that is also aligned with the way some of our models work right now, which is both scalable oversight on one hand, which both the places you and I work at are looking at, of course, where the challenge is that because of reasons of scale, but also because models are going to be more capable than humans, it becomes very difficult for humans to be in the loop and provide meaningful oversight. So that's a problem. We're finding that models are surprisingly good at monitoring one another, and this is an active area of research. To give concrete examples of things we want those monitor models to look at is find examples of reward hacking or deceptive alignment, for example, which now that we have this explicit reasoning step, and we do RL on chains of thoughts, it opens some really interesting, again, like short-term, very concrete research opportunities.
Thank you. I'm going to ask an audience-asked question, which is, what does success look like in all of this research, in AI alignment, safety, whatever you're doing? I think this is a good closing question for us, which is, imagine all your dreams come true and all your research is fruitful and then you get to what you want. What do those AI systems look like? What does that future look like?
I think the thing we lack right now that we absolutely need is basically guarantees. So high confidence statements of safety that are backed up by formal arguments. And if you look at nuclear safety, for example, the regulator does not design nuclear power stations. They don't test nuclear power stations. They just ask, give me a proof that the mean time to failure is at least 10 million years. And that proof, so you can imagine, well, how on earth would you do that, given that the life of any one component of a nuclear power station probably isn't more than a few hundred years. And so what's happened over the decades is that the designers have gradually developed ways of making systems that are much, much more robust than you could possibly imagine. And some of that involves sensors and monitoring. It involves maintenance, replacement, and all of those algorithms are part of what goes into that proof. And there's essentially a machine-readable calculation of the mean time to failure, which then the regulator can check and say, you made an independence assumption here, I don't like that. Go back and come back with something different. We are nowhere near, right? The analogy would be, actually FAA is maybe a better analogy to what we're doing. It's like you went to the Federal Aviation Administration, which certifies new aircraft designs, and said, well, instead of all that, engines and drag calculations and lift calculations and structural integrity calculations, we decided to breed really big birds. And they fly pretty fast, they're very fuel efficient, and they can carry people and a big thing underneath. And I want you to certify this new type of airplane. And the FAA looks at this and says, well, but they keep eating the passengers or dropping them in the ocean. So, where's your high confidence statement of safety?
Yes.
And they say, well, we can't provide one, but they're really cool, so you should certify them anyway. Right? That's the situation that we're in right now. And we have to get off that path.
Yes. Thank you.
Yeah, I think maybe I think Stuart might have like a specific end. I think success is inevitably going to be like a process rather than a state of being.
Yeah.
I think that success involves like identifying, building the infrastructure, the human infrastructure and the legal infrastructure and the technical infrastructure to continuously identify new risks and then to address those risks and then to act in a rational way, even if it means like delaying model releases or like limiting capabilities when necessary in order to prevent those risks from growing too large. So I think it's not going to be something where we reach an end state. I do think that we can approach something more like a steady state if we like, with things like responsible scaling policies and like more consistent best practices. I think we'll eventually have a system where identifying and mitigating new risks is like something that we do on a relatively regular basis, and maybe in some sense that's a success.
Thank you.
Yeah, building on what you just said, I expect there to be a lot of thankless groundwork on layers of mitigation, whether at the core model level or the systems around the model that maybe filter inputs and outputs, or maybe even a layer outside of that in monitoring usage and enforcement. Not everyone might be allowed to use models for whatever they want, but to try and end on a balanced or nuanced note, I recently listened to an interview by Elizabeth Kelly, who leads the US AI Safety Institute, and I loved her perspective because she emphasized the urgency to address the safety issues so that we can also leverage the benefits. And I like her view because she really embraces the dual use nature of these models sort of both ways, right? Remembering that if we do manage to make them safe, you mentioned the FAA. I don't know how many people are afraid of flying. I'm like maybe 10% afraid of flying, but I've been flying a lot, and luckily I know my rational mind knows that there's a lot of work that goes into making sure that most of the time airplanes work as intended. I think it's going to take a lot of work to do this for AI, but the reason I do what I do is because I believe the benefits can be pretty phenomenal as well. Thank
you. I'm going to insert a little story of my own here, which is that I was working with a colleague, a researcher, who was also an emergency room doctor at a big hospital. And we were doing an evaluation of this model that they had used, and we found, of course, errors that caused clinically significant harm. And then later on in a casual conversation, she mentioned that she uses that in practice. And I was very shocked. I said, wait, we found that there are errors here. How are you using this on people? And she was very shocked by my reaction. She was saying, basically everything I do in the emergency room is like that. There's always some things that work better, and there's always some risks, and there's a lot of work, a lot of groundwork that has gone into clinical trials and all these things and all these processes and institutions that make it so that we can have, a relatively safe hospital environment. And so I think it's really fruitful that we're talking about nuclear weapons, aviation, all these examples, medical institutions that have existed and have had these technological shifts, and people have somewhat, with some success, figured out the right approaches and structures and regulatory bodies for making sure that people can benefit from them while mitigating the risks as much as possible. I think we're almost done. I wanted to also close with a little shameless plug, which is that I recently went on leave from being a professor at UC Berkeley to start a company called Roya. And we're focusing on a lot of these similar questions of how do we build reliable agentic systems for enterprises. And we're hiring across machine learning and engineering roles. So if you're interested, hit me up. With that, I wanted to very much thank our panelists. This is a really, really interesting conversation. Thank you all for your questions. And let's thank our panelists one last time.